Okay, just to review 5.1 again, for those of you that are retaking quizzes or tests. 5.1, on the review you had before that, a few learning targets you need to be able to do. One is to be able to evaluate expressions with fractional exponents without a calculator. So all you got to remember is that whatever the denominator is, that's the root. So when you see 27 to the 1/3, you need to know that's the cubed root of 27 to the first power. So what number times itself 3 times gives you 27? 3 times 3 times 3. 16 to the 1/4 means the 4th root of 16. So what number times itself 4 times gives you 16? 2. 2 to the 4th power is 16. Now, if it's raised to something other than the 1/2, 1/4, 1/3 power, something like 4 to the 3/2, you're still going to take that root. So I'm going to take the square root of 4, but then the only other difference is now I have to raise it to the 3rd power. So this is still the root, and then once I get an answer, I'll raise it to that power. So the square root of 4 is 2. 2 to the 3rd power is 8. This one's a little bit tougher because now you have the 4th root of 625, and you want to cube that. We didn't really put anything quite that big on the tests, but you could sit and say, well, you know, you think it's got to end in a 5, so maybe you think it's 25. So if you took 25 times 25 times 25, no, that's not going to be it. If you do 5 raised to the 4th power, 5 times 5 is 25, times 5 is 125, times 5 again is 625. So you technically could just sit and, without a calculator, say, all right, I know 5 squared is 25. Multiply that by 5 again, and multiply that by 5 again. So you make sure that you realize it is 5. So now I know the 4th root of 625 is 5. I have to take 5 raised to the 3rd power for my final answer, and I get 125. The last 2 examples are just making sure you remember what to do with negatives. Remember, negatives just means you're going to put it in the denominator. So this is going to be 1 over the 4th root of 256, and that's going to be raised to the 5th power. And again, you might sit and think, I'm not quite sure what the 4th root of 256 is, but if you think about possibilities, it has to end in a 6, so it can't be an odd number. Might be 4, so if you tried it, 4 times 4 is 16, so that's squared, times 4 is 64, so that's to the 3rd, times 4 again is 256. So the 4th root of 256 is 4. So without a calculator, some of these bigger numbers you do have to think about a little bit, and then you want to be able to take 4 to the 5th power, which means you're just going to take this number and multiply it by 4 again, and you get 1024. And again, on quizzes and tests, we didn't give you numbers quite that big. I did want to talk about these, though, with the negatives. Like this one, I think we could put on a quiz. It's the cubed root of 27, and because it's negative, it's 1 over cubed root of 27 raised to the 4th power. Cubed root of 27, we should know without a calculator, is 3. 3 to the 4th power, well, 27 times 3 is 81. So it's 1 over 81. So just a few things you need to know from that learning target is that fractional exponents, that's the root that you're taking. If it's raised to a fractional power and you have a numerator, you take that root and then raise it to that power. If it's a negative exponent, remember you have to flip it into the denominator, so your final answer will be 1 over whatever that number is. Okay, second learning target without your calculator is being able to rewrite using exponents. So if you see something all underneath the square root sign, that means you want to raise it to the 1/2 power. So you have a couple options. You can write it as 2x, the whole quantity, raised to the 1/2 power. That means you would want to take the square root of 2x. You can take each of these bases and raise them to the 1/2. So 2 to the 1/2, x to the 1/2. Those would both be correct answers. So just to show that if you're going to take the square root of something, you raise it to the 1/2. If you take the cubed root of something, again, directions are just saying rewrite using exponents. So I'm going to take 5, or x to the 5/3, because I'm taking the cubed root but raising it to the 5th, and y to the 2/3. That's all you need to do on those. Same with this one. Now this one, you got to be careful. The 5 is already out here. So that's already just a 5. Nothing you can do with that, just 5 to the first power. But then the rest of this is raised to the, you're taking the 4th root of it. So you're going to take m to the 1/4, and you're going to take n to the 3/4. So again, I'm just taking the 5 stays there. It's m to the 1/4, n to the 3/4. You're writing it using fractional exponents. With this one, again, because it's raised to the negative first thing I probably would do is write that as 1 over square root of 5d. Again, this 5d is under a square root. So if you want to write it as 1 over 5d to the 1/2 power, that would be fine. It doesn't say anything about simplifying or leaving any radicals in the denominator, so you can leave it like this. You could write it as 5d to the negative 1/2 if you wanted to leave it as a negative exponent. You could raise it, say it's 1 over 5 to the 1/2, d to the 1/2, and raise each of those to the 1/2 power. The key is to know that anything that's underneath here is affected by this square root and this negative 1. So it's 5d to the negative 1/2 power. It could be 1 over 5d to the positive 1/2. You could distribute that 1/2 out to each of those. Any of those answers are correct. All right, and then the other thing you have to be able to do in 5.1 without a calculator is now go from exponential form to radical. So again, if I see this 5, I know I'm going to take the 5th root of a squared. It doesn't matter if you put the squared there or if you write it as a and square it out there. They mean the same thing. You're taking the 5th root of a, squaring it, or you're taking a, squaring it, and then taking the 5th root. All right, so with this one, the 4 is to the first power. So that stays outside the radical. It's 4 to the first. This is x to the 1/3, y to the 5/3. So I'm going to take the cubed root of x to the first, y to the 5th. And that's it. That's all you had to do with those. Same with 13. You have 2 to the 1/4, and you have x to the 3/4. If you want to break it up and take each one separately as a radical, which means I would take the 4th root of 2 to the first over the 4th root of 3 to the 3rd. And 3 to the 3rd is 27. So you probably would want to write the 4th root of 2 over the 4th root of 27. That would work. This I would give you credit for as long as you're writing this as a radical. You could actually also write 2 over x to the 3rd, take that whole thing and raise it to the 1/4 power, which means you take the 4th root of all of that. That also is fine because all of this is raised to the 1/4. Just take that base and take the 4th root of it. They all mean the same thing. Any of those forms are totally fine as an answer. And 7, again, you're going to take the cubed root of 7 squared, which I would like you to know that 7 squared is 49, and write it as the cubed root of 49. So that's really the first part of 5.1 without a calculator. Can you put a take a number and simplify it if it comes out evenly by looking at the root? So 16 to the 1/4, 4th root of 16, you should know. Again, some of these bigger ones I wouldn't worry as much about. Do know what happens though when you have negative exponents. You have to be able to rewrite radicals using exponents, and again, just be careful what's underneath the radical. Whatever's under the radical, that's the only thing that's raised to a fractional power. So if something is out here, it just stays as a 5. If it's all underneath the radical, then all of those things are affected by that cubed root. And then the last thing is be able to go the opposite way. If we give you something in fractional exponents, you can write it as a radical. So those are the 3 things you have to do in section 1 without using a calculator.